you know, public static void, whatever, you know, and then if you want to get a hold of that name, you have to create an object of that type. My class MC equals new my class. You have to instantiate it, and then you can get a hold of that name variable. MC.name is equal to Joe, or you could print it out, right, and it would print out Bob, whatever, you know, system.out.println. And that would print out Bob. And we could change it if we wanted to. But if we changed it, it would only change it for this one instance. So if I create two different variables here, should have made the class name shorter so it'd be easier to type. And then I set mc2.name equal to something else, Sally. And then I print out system.out.print, you know, mc.name. It's not going to print Sally. It would still print Bob because we only changed the name for the second object for mc2, not for the original one. Each variable that we declare is part of this class. And so when the new keyword activates, it goes and it creates an object with enough space for each variable that you list. What happens if you stick the word static in front of it? Static means once and only once. And just like I said in C++, all those variables are created even before the program starts to go. The same is true of this language. It goes ahead and creates space for that name variable, and it's outside of any object. Well, that's not true. It's outside of any specific instance of the my class. I guess I would say that it's outside of any object, but it is attached to the my class class, but it's not attached to any instance. So when we tried to print out mc.name, it would print out Bob, and then if we changed mc2.name to Sally and we tried to print out the original name, it would also be Sally, because this exists once and only once in the entire project, not once per instance. Now honestly, the Java compiler would complain about this at this point. It would say you're not supposed to prefix it with an instance name. You're supposed to prefix it with a class name. And if I made that change, if I changed that to my class here, and I changed, you know, that to my class here, right, and then I changed it to my class here, right, like that, it becomes real clear why it's going to print Sally, right? Because the name originally equaled Bob, and then, yeah, sure, we created a new object, but when we changed it by its class name and not its object name. And then when we print it out again based on the class name, it's changed to the new value. So that's what static means. Static means is that it doesn't change on an instance by instance basis. It applies to all instances. But even more so than that, it applies to the class, even if you don't create any instances. If this stuff was all commented out, these creation of these new objects, it would still print out Bob. And it would still print out Sally here. We don't even have to create an object in order to use that. And so that's why that's called a class member. This is a class member because it exists attached to the class as a whole, not to any specific instance. Now my one simile for this is metaphor for this that's kind of dumb, but it's about the best that I can come up with, is a class is a blueprint, right? And the object is a house you build from the blueprint. So you can build different houses out of different pieces of wood or different colors or different addresses, right? Every house is going to have a different address, and they can have different, you know, countertops and this, that, and those are all instance attributes, right? What kind of grass is painted in their lawn, you know. Every trait of the house is an instance trait. You feel like breaking all the windows in it, those are instance traits. If you feel like painting the walls orange, that's an instance trait because it doesn't change another house, it just changes the one you paint. But there's only one person's name on the blueprint, right? You know, invented by Frank Lloyd Wright, right? Every house made from that blueprint is created by architect Frank Lloyd Wright, right? Even if you don't build any houses, that blueprint is still created by Frank Lloyd Wright. The static members, the class members, are things that apply to the class itself, to the blueprint, and not to each version that you build with the new keyword, without each instance. Slightly abstract, but I hope that nailed it down. That make sense, guys? Yeah? Halfway? No? 2, do you like it? You hate it? Yeah, you hate it. No, I'm kidding. Alrighty. Alright, so the driver class is the class which actually uses your object. And sure, sometimes you have a class that uses a class that uses a class that uses a class. So the driver class for your one class, and then that class will have a driver for the other class that it's using, and that class will have a driver for the class that it's using. When we did our car with its wheels, main was a driver for car, and then car was a driver for the wheels. So they've got a little class here called mouse. And we might implement this for fun. Each mouse contains an age and a weight and a % growth rate. Well, let's do that, but we're going to add something to our mouse. We're going to give each mouse a name as well, because it's poor little lab rats, you know, they need their names. Now, when we create a class, we're not going to put it in the same class with the main method. Keep those two things very separated. The only time you should be sticking things in the class with the main method is if it's other code, if it's other functions that need to be called by main, not other classes that it's going to be used. You can stick methods, other methods inside the main class, but not your new classes. Now, can we stick them both in the same file? Yeah, I told you that you can, and the first time we created a class, I did that, and then I told you it's bad, so let's not do that. What lecture are we on? O, P, N? Okay, see if I can guess.
We missed L.
Right.
Last class was N, I think.
So this should be O.
Okay, so we're on O. Alrighty. Alright, so lecture O. Here's the way I want my class to work. I'm going to go down in main and write the way that I want it to work. I'm going to call it rat rather than mouse because I want to be different. Rat R1 equals new rat. I want to be able to give it a name, R1.setName, and this one's name is Ricky Rat. Let me sneak a peek at my my PowerPoint for a moment. All right, then I want to be able to set growth rate. So R1.set, I'm just going to call it rate. Growth rate's too many words. I want him to grow 5% each time. Except I'm going to make it a little bit easier, 5.005, 5%. I want to set his initial weight. Nah, all mice are born at the same weight. And then I'm going to call R1.grow a couple of times. You know, he's going to grow 3 days. And then R1.grow. And then R1.grow. And then I want him to display his information, R1.display. Or give a report, something like that. That's how I want it to work. Now I could show you something, but I don't really want to encourage you at this time to use it. Whenever a class name is underlined like that, if you click on the little NetBeans helper, you can create a brand new class. Now, I think in the past I've said never do that. I'm going to keep that recommendation for now. But if I did do that, it would go and it would make another class. in my same project with the name that was specified here. But I'm going to be conservative, not rely on that, so I'm going to go ahead and create a rat project, excuse me, a rat class. And so let me think about what I want in it. The rat class, if I was going to make a UML for it, it's got a name, rat, it's got to have some methods. It should have an age and the number of days. Make it look like a proper UML. It should have a weight, which should be a double because it needs to be fractional. It should have a growth rate, how much it increases each time, and it should have a name because we want to be able to give our guys names. So those are its variables. Now we should put getters and setters for every one of these things unless we don't want to allow them to use set. Now set age, why don't we just assume that all mice start off at age 0 and not allow them to do that? So we're not going to give them a setter for age, but we might want to give them a getter. If we look at my code, what methods do we absolutely have to have in order to match?
We need a set name, a set growth rate, and we need some grow functions and a display.
Yep, we need all of those functions. So let's implement those first. We need set name, and it's not going to return anything, but it takes a string. So that's going to be void. We need set rate, which is going to take a double, and it doesn't need to return anything. And if I was going to write full-fledged UML, I would need to be putting the data types here. And I could give them a lot better name than S and D, right? That's the name, and this is the rate. All right, Daniel, I've forgotten what is another one I need.
You would also need the grow function.
I need a grow function, right. So grow, it doesn't take any arguments, so I'm not going to give it any parameters. It doesn't return anything. Now we could make it return something like the weight or the age or something like that. And then we need a display method. Again, it doesn't take any arguments at this point in time, and it doesn't return anything. Now we could list what these things are supposed to do. Now setters are so primitive that maybe I'm not going to describe what it does. But here's what grow does. Add 1 to the day, increment the age by 1, and then increase weight by 1 plus the rate. Because if it's like 5%, then we need to multiply it by 1.05 to get it to its new weight. That's what the grow method's supposed to do. And then display, it's going to print the name, the age, and the weight of the rat. The setters just do what we expect them to do, so I'm not going to describe what they do. All right. I think I have enough information to go out and actually create that class. Something not making sense?
No, I wanted to type out display. Like,
Oh, and I covered it up. All right. Herp it up.
name, age, and weight. Okay, then I put it back there. No, that's alright.
We're good now?
Yeah, you can take
All right. All righty. So, need to make a rat class. I'm going to go to projects. I'm going to find my Lecture 0 package. Right click, add new Java class, rat with a capital R. Finish. All right, there's my rat class. I need to add some variables for it. I need to add all of these members. And all of these are instance members because they will change on a rat by rat basis. So I'm not going to make any of them static. So I'm going to say instance parentheses non-static variables. You don't have to put that comment. I'm putting it there to remind myself that non-static variables are instance variables. So, my rules of thumb from last week were make all your data private and your methods public, unless you have need otherwise. Oh, sorry. Yo.
Sorry, where do I put the Java file again?
What we're doing is we created a new class, so you're going to open up your projects pane, and then you're going to find your current package. Mine's called Lecture O. And you're going to right click and do new Java class there.
Okay, I kept taking up the package, so.
That makes sense?
Yeah.
You got it? Okay, cool.
So if you didn't have a package, it'd be default.
Exactly. Right. If I took the package word out of all of my classes, then it would be one level up. It would be right there. That's where I would do it. And I like not having packages. I just didn't change it this time. Okay, so we need an, as I was mentioning, our rules of thumb are data private, methods public, getters and setters. I'm going to ignore that one for now. Well, we do need two setters. And I don't remember if I had any others at that time. Class names, capital letter, initial cap, but that's not really as important as these three things. All right, where'd our variables go? So, private int age, private double weight, private double rate, and private string name. And do we want to give any default values to these? I say we do. Age needs to start off at 0. Maybe weight is always going to start off at 1 gram. I don't know how much a baby rat weighs, but that's... And then the rate, let's set the growth rate equal to 0 unless the user changes it. Right? Poor rat never would gain any weight. Or maybe just 1%. I don't care, because we are going to call set rate. And then the name can just be rat, right? Unless they change it. If you do not give default values to numeric variables, they default to 0 anyways, if they are instance members or class members.
Is that in all languages?
No. Yeah, in the ones that you're learning, like C++, it's true. But it's not true inside a method. It's not true inside a function. Those variables are called local variables. Local variables do not have default values. However, class variables and instance variables do.
So if you set a global one, it automatically will set 0?
Should. We could test that in C++. Next class period. Remember to do that. Okay. So we need some methods here. Set name, set rate, grow, and display. So these are instance methods. Instance non-static methods. Void set name, it accepts a argument that's a string, so we need a string parameter, string name. And my code's going to be this dot name equals name. This dot name equals name. Same for set rate. Void set rate accepts a double. So double rate. This dot rate equals rate. Now it's kind of lame not to put getters, but my code that I've got there doesn't need getters. I don't ask for it. So I'm not going to implement them until later. Maybe I'll let NetBeans implement the getters for me. Nah, that's too lame. It's bugging me. Let's provide getters. Now, what data type is a string? So what data type does our getter need to be? A string, I said that wrong. Yeah. Get name needs to be a string so that it can return its name, but it doesn't take any arguments. And it returns this dot name. Now do set rate and get rate the same way. Rate is defined as what? Lynn, how did we define rate?
It's a double.
Right, so get rate needs to be a double. Double get rate. It doesn't take any arguments because it's a getter. So we don't define any parameters, but it returns this dot rate. Now I'm going to do some condensing of my code to try to get it all on. Oh, well, that didn't work.
Didn't work.
There we go. So delete some spaces out. Try to get this all on one page. All right, there's our getters and our setters for our name and our rate. And we could do the same thing for the other things too, for the weight and the age. I'm going to hold off. I'm going to punt on that and then let NetBeans do that. I want you to be able to do it by hand though, so that's why I had us do it. Are we good? Can I scroll past this page, or anybody need me to slow down? Wave your hand if I need to slow. Nope. Okay. So we got two methods that we need to do. Well, yeah, we need to do grow and we need to do display. Grow is going to increase the weight. So, but it doesn't need to return anything. We could make it return the new weight or the new age or something, but it wasn't defined that way. So, void grow this dot weight plus equals this dot weight. You know what? I'm going to take the thises out because it's making the code too. In fact, I'm going to just expand this and then I'll leave it that way. Remember that you can leave the this keyword off in most circumstances. This dot weight is plus equal to this dot weight times the rate. This dot rate. And yeah, there are other ways of calculating it. Now display, I just want to print some information about the rat. So it doesn't take any arguments, it doesn't return anything. We're just going to have some print statements. System dot, let me scroll this up. System dot out dot print. Rat name equals end quote plus name. Plus maybe a comma, so quote comma space end quote end parentheses. Now really I should have used printf. I'm already beginning not using printf. So I'm going to change this to use a printf. I'm going to delete everything between the parentheses. So quote rat name equals %s because that's a string. Age equals %d because it's an int. Weight equals %f because it's a floating point. And I guess we may as well print its rate out as well. Comma rate equals %f.
They entered the rate though.
Yeah, I'm kind of waffling about, but they entered the name too. Let's go ahead and print it out and then \n. Now after my comma, I'm going to go the next, excuse me, after the end quote, I'm going to go to the next line. And I'm going to print out this dot name, comma, this dot age, comma, this dot weight, comma, and this dot rate. Now, if we did this right, if I didn't make any mistakes, then my main code may already be perfectly working. I may have implemented my rat well enough that I don't have to change main. I'm not sure of that. There's a comma after that, if you remember, even though you can't see it. There. Let's find out. I'm going to build it and run it. See if by miracle of miracles I have any errors or not. All right. So, I forgot to do something. I increased the weight,
It's not working here.
but I never made them get older. So, I need to go back into my grow method and do what? Vincent, tell me what I'm going to add here. Yeah, I need to increment age. This dot age plus plus. Each time we grow, he grows a little bit older.
Oh, that's what you missed. In the pseudocode, you put age first. I didn't realize.
Yeah, I forgot to implement that. My mistake. So I could cut that and paste it above there if I wanted to exactly model. All right. So now when I run it, yep, his age is 3. We could make a little loop that would keep him aging as long as the user wanted to, right? You know, hit return, hit return, hit return, and so on. Why don't we put a for loop that, you know, runs 10 times and ages him 10 days?
I
And
mean, let's see what a 100-year-old rat would turn out.
all right, yeah, let's do that. He's going to grow for 100 years. 100 times 365. Okay, so instead of calling grow like that, for int day is equal to 1, day is less than or equal to 365 times 100 because he's going to grow for 100 years. This is a, I tell you what, I'm just going to go up to 365. And then day plus plus, call r1.grow, like that. What did I do wrong there, guys? Yeah, this is a method call, and I didn't put my parentheses there. There we go. But why don't we display it each and every time? And so if we're going to display it each and every time, would this be adequate? Would this work for me? If I did that, would that display it every time? For Python it would, but in this language, indentation means nothing and we have to block things off with braces.
And so in Python, indentation actually means it's a part of.
Exactly. Exactly. Kind of cool, kind of horrible. Alrighty, so he starts off small, but when does he hit being a kilogram? Alright, after 140 days, our rat weighs 2.2 pounds. And then he keeps growing until he weighs, oh well, you know, an unimaginable amount. So that's kind of silly, right? After a certain point, he should stop growing, or his growth rate should slow down or something like that. But anyways, hopefully you get the idea. Each mouse has a set of attributes. We could create more than one mouse, and we could age them at different rates, right? Let's create another mouse. Rat R2 is equal to new rat. And R2 dot set name, parentheses, Sally. Sally's a girl mouse. She grows a little bit more slowly, although a lot of animals, the female is actually larger than the male, but let's ignore that. Set R2.setRate 0.04. Grows a little bit more slowly. So in our loop, not only do I want to call R1.grow, R1.display, I'm going to also call R2.grow, R2.display. And maybe I'll lower the number of days to like 20 or something. R2.grow, R2.display, and I only want to print out 20 days worth of information. Or 30, a whole month. Alrighty, there we go. Alright, so after 30 days, Ricky does indeed weigh more than Sally. And if we kept the simulation going, like back out to 100 days, then the weight difference would be dramatic, you know, because it would build up over time. That 1% difference is significantly different over time. Check it out. Is that in the millions? No, that's in the millions, and this is like 54 million grams, whereas Sally weighs 1 million grams. So Ricky weighs 54 times as much after 365 days. That 1% just built up a lot. But we could see we have 4 instance members. We have the Sally, we have the age, and we have the weight, and we have the rate. Now I want to broach a topic, which is the idea of the constructor. The constructor is a method that gets invoked by the new keyword. There is a default constructor provided by Java, so I did not have to write a constructor. But I could. I'm going to go back to my rat class and add a constructor. A constructor, and I'll type this in my notes. A constructor is a method that has the same name as a class and no return type. So a constructor is a method that has the same name as a class, or the class, no return type, and is invoked by the new keyword. So big deal, what does that mean? Well, you could use it to initialize the values. So I'm going to go back to my rat and I'm going to create a constructor. Constructor. Oh, and I forgot to put public in front of all my method names. The default is something close to public. It's package, which is public, but just inside that same package. I should go back and add public to these. But anyways, so public, and I don't give it a void or anything. It has no return type at all. Rat. It's not going to accept any arguments yet, so I'm not going to put anything inside the parentheses. And let's say that these are weird rats, and this dot rate is now equal to 100. When we create them, they start off being 100 grams for some reason. Yeah, it's the super rat. Okay, so when I run the code now, the rates, oh, I meant to make that weight. Excuse me. This dot weight is equal to 100, and this dot age is equal to 50, right? These animals start off more. They're older and they weigh more by the time we start doing this stuff. So now when I run it, and I'm going to change my for loop back to 10 or 20 so that I don't have, 20 pages of output. That's my constructor. It'll be called by the new keyword. So if I come back here, and then I print out R1.display and an R2.display, and then I'm just going to age, system.out.println, no, system.out. Is it read? Is it get? Oh, come on, guys. Tell me how you get input.
Scanner.
Oh, yeah, I need a scanner. All right. Okay. Well, temporarily, you don't need to do this, but I'm going to do it. I'm going to comment out this code. I'm going to uncomment immediately, so you don't need to do it. But I just want to show you that as soon as the rats are created, their age is already set to 50, and their weight is already set to 100. That's because as they were created, that's what the constructor does. As soon as it hits the new keyword, as the object is being created, that variable is set to that, and that variable is set to that. And that's kind of a, yeah, big deal, right? Because I could have set those there. Yeah, but we could accept these as parameters if we wanted to. So bear with me on this one. Delete those two guys. Let's not change those values here. But we're going to make a second constructor that does set the instance values. So this one needs to accept parameters. Public rat, it's going to accept a name, and it's going to accept an age, it's going to accept a rate. Is that enough? How many instance members do we have? And a weight. And what is it going to do? This dot name equals name, this dot age equals age, this dot weight equals weight, and this dot rate equals rate. This dot name equals name, this dot age equals age, this dot weight equals weight, and this dot rate equals rate. And then I'm going to go back to main and I'm going to create a third rat. But I'm going to provide all these parameters. I'm going to provide arguments for them as I'm creating it.
I think I missed something. Because it's telling me class interface being unexpected. Is it supposed to go active?
I wonder if you have too many close braces. Let me come look. So this here is a default constructor. Doesn't do anything, right? Doesn't set any of the variables. And that's okay. I don't mind it being there. You don't usually have to put one there. Java provides one for you under certain circumstances, which I will explain in just a minute. But then this is what's known as a parameterized constructor because it accepts parameters. I'm going to change my comment up here to default constructor. And I'm going to call this one the parameterized constructor. Then I'm going to go and modify main to use this fancy new constructor. So over in main, let's create some new rats. Rat R3 is equal to new rat, and this rat's name is Bubba, and he's 10 days old, and he's 5 grams, and his growth rate is 0.01. And then rat R4 is equal to new rat Sammy, end quote, comma, he's 100 days old, he weighs 10 grams, and his growth rate is 0.02. So you see how easy it is to create objects of this type. I didn't have to call set name and set rate. If I had implemented setters for the other ones, I wouldn't have to call, Anyways, if I wanted to create a plain ordinary rat with all default values, rat R5 is equal to new rat, and then just all default values, like that. So these values are overriding the default values. And that can be useful. Like, what if you have a block class? Without the constructors, what we've been doing is like set height and set width and set depth, right? Or whatever our three variables were called. I guess I'll call R3.display, R4.display, and R5.display just to see those. All right, so here's our last three rats. The default one has the name of rat, his age is 0, his weight is 1, his growth rate is 0, but then we have these nice customized rats. So with a constructor, our block class could do this. Block B1 equals new block with a height of 10, a width of 20, and a depth of 15, right? And then another block B2 is equal to new block, and it's just a 10 by 10 by 10. That's a lot cooler than going B1, you know, block B3 is equal to new block, and then having to set those things individually, right? B3 dot set height, you know, 30, whatever, set width, and so on. So I'm going to add that to my rules, my little rules of thumb. Data private, methods public, add getters and setters, add constructor if it makes it easy to use. Add constructor if that makes it easier to use. All right, so we've got 5 rules so far. Class name is kind of trivial. These are actually architectural, right? So we've got 4 rules so far. All right, I'm going to go back to the idea of the this reference again. When is it necessary? When is it not? The only time it's necessary is if there's the possibility for confusion between which variable is being referenced. Here we have a parameter called age. Here we have a instance member called age. So if I did this, age is equal to 75, which age is being set to 75? That one or that one? And in truth, it's that one. This one has masked that one, right, because it's the most recently defined one. So if I want to change that variable to 75, I have to say this dot age. So if the parameter names match the instance names, then you want to use the this keyword. For things like this, I hate that. If you see this example, we have a parameter named name, and so we had to use the this keyword as well. For get name, do we have any parameters at all?
No.
So do we have any name conflicts? No. So we could just do that, return name. If you think that's cleaner, great. I like the this keyword because I can type this dot and it pops up all my variables, right? And I can save time typing. But they're not mandatory unless there's name conflicts. So setters, always use the this unless you're going to change the name of the parameters to something that doesn't match the variable names. Constructors probably are going to use the this keyword. The rest of the time you can probably get away without it. I think it makes the code easier to read. If you don't agree, that's okay. Alrighty. Oh, one more thing I need to mention. Why did I bother putting a default constructor here? Right? Because I said that Java provides one for you, and we proved it, right? We didn't have one to begin with. Comment it out and see what happens to your code. And what you'll find is that your main method is now broken, right? Once you provide a parameterized constructor, Java removes the default constructor and you have to put one in yourself if you want it. So now that I have a parameterized constructor, these don't work. I have to go and put back in. So as soon as you add a parameterized constructor, think to yourself, do I need a default one? And if the answer is no, if you want to force yourself or the other programmer to use your parameterized constructor, leave the default one off. But sometimes you have like, millions of pages of existing code that are all taking advantage of the default constructor. And then you decide that you're going to be cool and add a parameterized constructor. Well, that breaks those 10 million pages of existing code, so you better go ahead and put a default one in as well. That's important enough that I'm going to make a reference to that in the notes. So, default constructor has no parameters. Typically just sets the member variables to default values. If you have not already provided default values when you declare the variables. Parameterized constructor has parameters and sets the member variables to those parameters. Once you provide a parameterized constructor, by default, Java automatically provides a default constructor. Guess that's why it's called default. It's added by default. But once you add a parameterized constructor, the default constructor is no longer automatically provided, so you have to create it. So maybe you could make a language where you said that every time you make a class you have to add a default constructor for it, right? The language is not going to provide one for you. But sometimes you'll have classes that don't need a constructor at all because it's filled only with static methods. And let's make an example of that. We're going to make something to do with math, but I'm not going to call it math. I'm going to call it something else. Mathy or my math, something like that. Let's add a brand new class called my math. So I'm going to go to projects, go to my package, right click, and it's going to be full of static methods. New Java class, I'm going to call it my math. Finish.
You're in the same project?
Yes, put it in the same project as your rat class and your normal class, your main class. Okay, so what is my math going to do? It's going to have two functions, an add and a subtract. So public int add takes two numbers, int x and int y, and returns x plus y. And then another one's called subtract that returns x minus y. Public int sub, and I said I was going to make them static, and I haven't added that keyword, so I'm going to have to go back and add them. Public int subtract int x comma int y, which returns x, take the s off, return x minus y. But make them static. So public static int add and public static int subtract. Then I'm going to go to the main class. You know what? I should have done a multiply one because we use multiply. Anyways, yeah. We'll just go and add something to main to call these functions, to call these methods. So when I get to main, I'm going to do something like int x equals mymath.add and then pass in two numbers. And int y is equal to mymath.subtract. So I'm going back to my main class. Doesn't matter whether I do it at the top or the bottom. I'm going to add it to the top. Int x equals mymath.add 10 and 20. and int y is equal to my math dot subtract 100 comma 10. And I could print them out, but whatever, right? We know that the first one's going to be 30 and the next one's going to be 90. All right, so why did I make those static? Because I don't want to have to create a new math class just to do add and subtraction, right? I had to create a new rat because every rat has potentially different values. But my math class doesn't even have any data. So if a class doesn't even have any data, you may as well make all the methods static so that you can use it. Now notice when I call these methods, these static methods, they are prefixed with the name of the class. And when I call these methods, these non-static methods, they are prefixed with the name of an instance. So setName is an instance method, and add and subtract are class methods. Add and subtract are static, so parentheses, class methods. And then down here, I'm going to say setName and setRate are non-static, parentheses, instance methods. Does that make sense? If you're just going to add some utility functions somewhere, and you don't want your thing to have to create a brand new object just to use your utility functions, then make them static, right? These methods also could have been added to our main class, right? They didn't have to be put in their own math class. Why would I put them in their own class? So that I could bring them into other projects, right, without copying and pasting code. You know, I could publish this to a library and I could import, you know, that library anytime I wanted to do some addition and subtraction. So the math class that ships with Java comes with a boatload of static methods, you know, sine, cosine, tangent, power of, absolute value, and stuff like that. You don't need to create a math object in order to call sine, cosine, tangent, or whatever. The scanner, though, the scanner, you do have to create an object before you can call next int or has next double or things like that. So the the scanner class, those are non-static methods. Those are instance methods. You have to create an instance before you use them. We are just about done, and we didn't even get through one page. All right, we did though, because we implemented our own version of this mouse class. My code may have been just a little bit different, but not much. While we're thinking about it, let's go ahead and add some setters to our rat, okay? So I'm going to go to rat.java. I'm going to highlight all of the variables, and I'm going to choose Refactor, Encapsulate Fields. Now some of them should already have been created, right? We had a set name, and we had a set rate. So I'm surprised that that's not indicated somehow. But anyways, now they're all checked. And so if I click Refactor, it goes into my code and adds all the getters and the setters. And it looks really ugly. It's added java.comments for them. It puts them at the top of my class before my, before my instance variables. So typically I cut them and I move them down and I remove the java.comments. But that's a cheap and easy way of adding getters and setters. Just highlight the variables and do refactor, encapsulate. And again, why do you encapsulate your data rather than allow programs to access them directly? Well, maybe you don't want to allow some other program to set the age of the rat to a negative value, right? Or to set the weight to a negative value, or the name to an obscene word. Well, you can make your set method prevent negative age values. If I find my set age method, then I could check. If age is less than 0, then age is equal to 0, right? That would forbid them. That would disable the idea that somebody could accidentally set the age to a negative value. And I could go into set weight and do the same thing. So the point of having getters and setters is that you're trying to maintain the integrity of your object. You're trying to maintain all of its instance variables in a valid state, so that any time it is accessed, it is valid, and you or another programmer can't goof up and accidentally set those values to things that are invalid. Like what happens if we set the growth rate to 0, you know, then it's not going to work anymore. Or a negative growth rate, well, it gets smaller every time you call it to grow or whatever. So that's the idea of encapsulation. You're keeping your data safe. You're putting it in a capsule and you're only allowing it to be changed in whatever ways you, the programmer, dictate. And then later on, when you use that class, you have to follow the rules that you set. Now, if you're the only programmer in it, is it a waste of time to go in and add getters and setters? Well, yeah, maybe, but look how easy it was to do, right? I just had to, you know, highlight everything and, you know, click refactor, and boom, it was already done. So no, it doesn't take any extra time, and it makes your code a little more bulletproof. And if you want to later go on and add some safety checks so that, you know, in this particular case, if we didn't want to allow them to change the age at all, we would just delete that method. You don't have to have setters, you know. Maybe you only have getters. Maybe we only have get age. You don't have to have getters, right? What if that variable is only used inside the class and the user doesn't even need to know about it, right? Like if you have some file class and you can specify a file name, but then that file name gets hashed to some specific, you know, ID number that the other programmers never need to know about, then that variable could be made private and you wouldn't even add any getters or setters for it. That variable would only be used by the class, so it doesn't need to be exposed. It doesn't need to have any holes in the capsule that could affect it. All right, that's about enough. My voice is going out and I have a whole nother class to teach. This is going to be exciting. All righty. All right, this is going to be really annoying if I say modify your block class again. So here's what the assignment is going to be. No, can't do that because I've already drawn the UML for the rat class. That's sometimes what I have people do, is draw the UML for the class. But I don't think I ever provided a UML for the block class. Maybe I did. Let me go in and look.
Would we do a UML maybe on Thursday?
Yeah, we did one for the rat. But let's see, the block. Did I provide a UML for the block? No, I did not. Okay, guess what? Y'all get homework. Here's the homework. Add a default constructor and a parameterized constructor to your block class. Modify your main to use the parameterized constructor. Why are you adding a default one? So it doesn't break your code once you add the parameterized constructor. Then draw or create a UML diagram for the block class. So what are you going to do? You're going to list its name. You're going to list all of its variables. You're going to list all of its methods. If a variable or if a member is private, put a minus sign in front of it. And you know what? If you do this in Word, it's a real drag because every time you type in minus, then it tries to create, you know, lines or dashes or hyphens or stuff like that. So I would just create this in a text editor. That's what I would do. And I'll show you what I mean while I'm making a Dropbox for this.